tired. The show must go on. Had a couple of drinks. That'll wake me up, right? Had one. I'm gonna start this up and then go watch a show with the missus. Go watch the new episode of The Mandalorian. But before I start, so I added pressure. By the way, anybody who's watching, this is all just documentation that I can go back and reference and pull these videos, and it's an easier way to save all the video information. That way I don't have to save it on some limited hard drive space. So I put PTFE tape around the top. Decided to go with that instead of the carbon because it should be less thermally conductive and should be able to withstand. It's a high temperature PTFE tape, so it's up high away from any reaction site, so it should be decent. I made a little relief valve, just punctured a little hole in it, so a little bit of so the hydrogen will still build up, but it will be it won't be as much pressure to. It won't be like the last experiment where it doesn't build up any pressure, and it won't be like the experiment before that where it builds up too much pressure. That Goldilocks zone, trying to make that thermoacoustic resonation happen. So we shall see. So take a start temperature. This time I'm going to run just a slow hydrogen build up experiment or build up like a preheat first before I try to get the plasma going. So we're at 24/7, which sometimes feels like the story of my life, going 24/7, and then we're at 24/7 Celsius. You're gonna have to excuse the cheesy jokes. Jokes get cheesier the more tired I get. So to anybody who is watching this shit besides myself, but so let's get this study successful. So let's give it a shot here. About 18 volts DC. We have hydrodynamic flow. You can see in the carbon, nanoparticulate carbon. So it's fun to see. Magneto hydrodynamic flow, because there's a magnet in the bottom of there and a magnet up top. Looks pretty good. Not as much clearance as I wanted down below, but it should still be enough. Let's see if the stream is live and looking good. Yep, we're live and looking good. Not as much clearance as I wanted down low. Good. All right. So it looks like I might need to make less of a relief. I may not even need to make the hole. I may have not needed to make the hole because the PTFE is on the outside, so the pressure should push it. It might have been better just to keep it like as a diaphragm where the pressure builds up and pushes it to release. Probably be a better way to go, but I wanted to give it a little hole anyways, but it's an easy fix, so we'll see. So I'm going to increase the power a little bit and see if we can get pressure buildup. Definitely seeing some cyclonic action in there. .70 volts. About 62 watts. I also pushed the ceramic up to try to only make that tip be the conductive spot. See if that worked. Probably not, but I don't know. We're looking pretty good. Well, we're at 60 watts. Do have a relatively strong magnetic field. I'm going to get rid of my ugly mug so you guys can see the. Actually, I'm going to just move it over here. Give it symmetry. Alright, well, I think I'm going to push it and see if we can get plasma now. Actually, I'm not going to wait too long because I really just want to test to see if it pulls too much current. So let's give it a shot here. Yeah, it's pulling a lot of current. Yeah, it's pulling too much current. So we need to fix the electrode. Need to fix the cathode. So I'm going to do that first before I go walk away from this and build up the pressure in the cell. And go get another drink so I don't fall asleep. Cool. Do it right here. Oh yeah, no wonder. Thought there wasn't very much clearance. It actually came out. So maybe this will be an easier fix than I even thought. So there's the PTFE tape. There's a little relief hole. And I think I'm just going to PTFE tape it all the way. I can do it without it being too ugly here. Don't want any PTFE tape drifting in. Potassium hydroxide makes it a little slippery. There we go, just a little. There we go. There we go. Relief holes right there. This time, I made kind of a big relief hole. This time I'm going to make just a little incision. That. Just a little incision. Doesn't help that it wrapped it in two different directions. There we go. All right. Go. Just check everything here. Make sure these are all good and tight. A lot more slack. That would be too much. We better keep it like low. That. All right, let's give that a shot. Wish ceramic wasn't so expensive. I would buy a whole freaking tube. I actually did buy whole tubes, but they were just a little too the outer diameter of this was just a little too big, because the specs that they had on this were not quite accurate. I guess I could like sand it down, but it'd kind of rough it up, which probably doesn't matter too much, but we'll see. We'll give this a shot. I know I'm excited. Are you guys excited? All zero of you watching? Let's fucking go. Okay, here we go. Good. Plug it in. Check the temperature again. 26.7. Hello. I'm almost done. Myself. Let's go. Let's fucking go. You can come join.
Is it live?
Yeah. There's a whole 0 people watching right now.
Is it live on you?
Live on me?
Yeah.
I mean, I could not make it live on me and just live on the reactor. Give them a show.
Who's them?
A big goose egg.
I'm not into gooses.
You're not into geese.
No, I'm not into gooses.
You made me forget my temperature measurement. You're distracting me. 26.7. 26.7.
Okay, so you're almost done?
I'm almost done.
Okay. Put your pants on.
You're not supposed to tell them that. You're not supposed to say that. Oh shit, someone's watching. Alright. Let's fire this up again. little more clearance on the bottom now. Is our still haven't solved that issue here. I feel like that should be something else. Yeah, that looks more accurate. So there's our test peak right there. I tried fixing the watts. 100 watts? Huh? That looks about accurate, so it should have worked. 2 watts. I don't think it's 2 watts. I also put in the kilowatt hours. That should just be a exponential function. It should just go up. Alright. Reading at the RMS is reading it around 4.45 out of the wall. Yeah. That makes more sense. 17, 18. We'll call it 18.5. 18.5 volts DC. What's up?
You monitor your chat section.
Why? Is that you? Is it you? You're the only person watching?
No, there's someone else.
Okay, cool. Yay!
But you're not monitoring your chat.
Why? I'm sorry, I was in the middle of something. Did you?
Wow. What
Did you say something?
What a host.
Say something again to make sure.
I will.
Oh, there it is. There's a delay. Yeah, there is a delay. Oh, you're right. The chat is off. Why? Should be up at the top here. Should be working. It's not working. Why is it not working? Yeah, there it is. It's just delayed. It's just jacked up. There's the live chat. Thank you for testing it. Alright, let's do a little pressure test and see. Might not have needed to make that relief valve, but we'll find out soon enough. It's not looking good. 76 watts, and it looks like the pressure is reversed for some reason. Because the water level raised in the quartz tube. I'll put this over here. Move the electromagnetic field meter closer to me. Alright, well, it's way too much current. 300 watts. So, once again, we have pressure failure. See if it gave me the. I got 300 watts. This is only reading 190 at peak. All right, babe. Give me like 10 more minutes, okay? because I want to get the pressure thing working on this. So I'll give it one more try. If I don't succeed, then I'll give up. But if you want, may I please have another, ma'am? She can hear me in the other room better than she can hear me on camera because there's a delay. Let's see.
What'd you say?
May I have another?
Is when you come up in here.
Okay. Did you hear what I said?
No.
Oh, okay. Give me like
Say,
10 more minutes. I
I
want
need to have my second one too.
to try. I want to try to fix the pressure on it.
Hurry up.
Okay. 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 Off. Unplug for safety. All right. I have enough of this PTFE tape. I'm just going to redo the whole thing. Kind of a waste, but it's getting all stringy and looking like garbage. And I'm not sure if I showed this, but there's where I made the relief cut. Pressure. And I'm going to completely cover it this time to see if I can build up pressure in the resonating tube. And work backwards from there. I think that'd probably be smarter. Work smarter, not harder. That's what my pappy always said. Alright. That's quick. Son of a bitch. I just chipped the tube. It's still whole, but just hit it up against the thing. Oh, good job. As long as it's still intact, whatever. Okay. It's primarily just a stress test anyway. Oh yeah, my apologies. I'm just putting a PTFE tape around a relief hole on the quartz tube to build up pressure. Because two experiments ago, right, I was building up too much pressure and the oscillations were slow. In the last experiment, I didn't build up any pressure and it was pulling too much current because the ceramic that's around it isn't really preventing the electrolyte or the the solution to stay away from the electrode. So here we go again. Trial and error. So I'm not seeing a voltage raise on the scope though. There we go. Loose connection. There we go. Okay. Once again, does not look like pressure is building up. So it might be another failure. I'll have to wait until tomorrow or Sunday to work on it some more. It's likely the ceramic piece that connects on the top in between the tube has holes in it, or allows for pressure to go. You can turn it up and test it, but yeah, it's just gonna start dumping power. Yeah, I'm having some sealing issues at the, and it wasn't last time. It built up pressure really well, but then I redid the whole top of it, so because I broke one of the quartz tubes, making it too tight on the top when I twisted it in. After you cut the quartz tubes, they can be really delicate. Yeah. Yeah, I don't want to permanently seal it though. I don't want to seal it that much. But those are both good. And then also silicone. No, silicone's a good. Yeah, that'd be a good way to seal it. But I don't want to permanently seal it. So I'm just using PTFE plumber's tape, basically high temperature plumber's tape. Dumping power into it now. There's too much surface area. the cathode. It's a no-go tonight. Yeah, 230. So at least I got the watt meter. It seems like it's working better now. The watt monitoring, the data acquisition. It's more accurate. Well, maybe I can do this real quick. I told her 10 minutes, so. This time I'll do like you suggested, John. Make it bigger for you. So it's probably not this. Oh, maybe actually. There might be that right there. Let's take this off. Take a look at it. It's kind of hard to see. That might be it. Let's add a touch more. Right at the top of his lip. Like I said, if I add too much, that's not a problem, then I can make a little relief. A little relief hole. Alright, we'll try that. It's not too tight. Oh, that sounded like I broke it. Alright, we'll try that. PTFE might be the only thing holding it together right now. On the top. Oh, you know what? Might not be super important, but that looked like it worked because it automatically sucked up water like a straw. Oh, now I know I broke it. Damn. For sure, I heard it break there. Yeah, sucking up water. Yeah, no problem. Alright. One more attempt here. Volts. Yeah, there we go. Slowly. Slowly. So if we add more power, might be able to increase pressurization. But still dumping a lot of power, so it's not perfect. And I totally broke that quartz tube. Which sucks, which means I have to cut another one. Only got so much left. I'll have to move on to ceramic anyways. It's going to be a lot more expensive. So, still might not be enough. Kind of rushing it. Usually I let it warm up a lot more. It makes it easier for the plasma to initiate. Rushing the process. Yep, you can hear it. You know what it sounds like. It's a lot more power there. 212. Got 270 on the digital. 46. Yeah, I'll try to go for it here. Might as well. Yep.
Oh yeah, it is. Okay, cool.
Just trying to rush it too much. Hey, Corky. Yeah, well, the ideal is to engineer a way to do both cavitation, like electronuclear collapse, like Matsumoto talked about, and then I don't know if you guys have looked into this in the like standard physics, but if you look into the Schwinger limit, it's pretty similar to kind of like this concept of 0 point, just this fall off into infinity. Yeah, for sure. There's lots of, because we gotta, in order to sort out what the hell's going on, the cavitation does seem to play a part in it. Like when you have that collapse, an incompressible fluid, it's very, very fascinating. .60 is building up pressure, but now it seems like it might be too much. I might be overshooting it now, so I'm just gonna leave it to where it's just on the cusp. Archiver, long time no talk. noticing two things. One is that the electrode's too low, or the quartz tube is too high. Probably be within like a quarter of the actual tube. This new electrode is a lot harder than the wire. This has got so much more surface area, so you really have to limit the current. Right now, approximately 75 degrees C. I still haven't been able to make the mass flow happen. I keep having problems with. I have to spend more money. Basically, is what it comes down to. Still slow oscillations too. I just have to get, I should just do some calculations on thermoacoustic waveguide. I think needs to be like a quarter inch at least, or a quarter of the way of the tube inside. I tried once with an ultrasonic speaker, and I've had no success. That's a really good idea. It's something that I would like to explore more, John. So if you would like to do that, because I know that you do these too. I tried one of these piezoelectric transducers, and I didn't pick up anything. I didn't put it in the solution. I just put it underneath. So. But I thought about that, like capturing the sonic spectrum for sure. Yeah, Corky, you're more of the artist, philosophical type of person. You might like it. I wrote this paper called The Energy Freedom Paradox. You might like it, man. It's on the website conscious.energy. I don't know if you've seen it or read it. It kind of goes over the whole free energy thing, and I bring up the allegory of the cave, Plato's cave, and how we can't see past our own nose sometimes, type of thing, you know. We don't know, we're like a fish in water, you know. Keeping an open mind. Systems, dynamic, complex systems, complex numbers. Yeah, it's the same oscillations though. Definitely big pops. I need that quartz tube down a little bit, I think. Alright. I better go too, because the missus is waiting for me. The nice thing about live streaming these things is I can just keep it going. That was my hope. I'm still trying to do the stress test on the materials used. So we had this initial startup, 420 watts. That's purely coincidental. And then sort of averaging around 162, about 160 watts probably. But I'll let it pop like this for a while. We'll see what happens. Oh yeah, for sure. For sure, you can hear him. And the trick is to make that that whole quartz tube like a thermoacoustic resonator, right, where you hit that fundamental frequency that oscillates it very well and creates either, I don't know, hypothetically a standing node or some type of peak node, but preferably like a standing node to keep all the hydrogen collapsing on that one point, right, for cavitation. So all right, turn it down a little bit. I'm gonna let this run for a bit and go watch a show with the missus. Thanks for watching, guys. I'll be back later tonight. It's gonna be a little while though. But yeah, enjoy. Feel free to talk amongst yourselves. I'll read it later. So take care. Oh, I'll get one more heat measurement before I go. It looks like it's, yeah, I pushed it really hard. It's 87. Yep, 87.3 Celsius. But I pushed it pretty hard. All right. Talk to you guys later, unless you're on in a couple hours. Peace out. just realized that wasn't working, so it came back out. Also, I want to get a temperature measurement of this. Stop boiling, as you can see. And also, I need to update this. I gotta fix this graph too. So, clear power reduction. We're somewhere in between 100 and we could call it 80. Do the calcs on that too. I really want to be able to freaking temperature monitor this. I just wish I didn't need a ultrasonic flow meter and a dosimetric pump. 300 some for $500 if I want to get a nice one. Also, the missus is not ready. She waited too long, got engrossed into a show. Change a trigger on that. I'm going to try to auto it. Sense. Needs to do that more often. You can oscillate like that for a longer period of time. That's when the magic happens. You ready now? You ready? Yeah? Okay. Yeah, well, you got engrossed in the show. There we go. You can see the spikes. Should probably invert the measurement. It's hard to catch it because it's so sporadic, but you can do some freeze frames. It's also a lot of power. I think if I go to channel 2 and scale that back a bit, might help. And then I should mess with the trigger, but it's a pain in the butt to mess with the trigger on the computer. That was nice oscillation. There we go. It's a little cleaner. Man, it's noisy. see when it oscillates there. Yeah, look at that. That's cool. Okay, that's much better. And then I can pause the video and do measurements that way. No, I don't, because it's so sporadic. I've measured it. I've measured it occasionally, but it rings and it clips off. You can see it there on the scope, but it's so sporadic because I haven't really locked it down. Man, this sucker is boiling like crazy, huh? We're at 95.3. Realize I probably need something under this. Don't want to corrode the crap above it. Or something above it to collect. Yeah, so I don't have steam. Alright. Now I'm going to go hang with the missus. Now I fixed all that stuff. Keep an eye on the live stream. So if I don't see you in an hour or two, tonight I'll show the results for the degradation on the cathode. That's the main test of this, is just to kind of stress test the new cathode and the quartz tube, see if it will survive, or if I really do. I'm pretty sure I need to move up to the ceramic for if it's going to be a long-term like run. But and once that plasma goes, though, man, it boils. Boy, does it boil! Holy crap! And I thought it's got to be a combination of temperature's gone down a bit. Nope, never mind. It's like 95.5. It's not the most accurate temperature measurement. I really need to get flow calorimetry set up. Yeah, no, it's a great idea. It's a good idea, Josh. I keep calling you John. I was obviously reading that wrong. Yeah, I have considered that, and it's something that should be done for sure. What do you suggest for a good audio spectrum analyzer? I wonder if I could run it just the video. I have a spectrum analyzer actually on my computer, on my main computer. I wonder if I could just run the video through it and it would pick it up. Or I probably need to take other measurements to really filter everything out, huh? That was good. That was good. Need more of that. Need to be able to make that continuous, where it just will oscillate like that. It's pretty cool, but who knows? Maybe I'm just fooling myself, right? Sure looks cool. Alright. I'll talk to you guys later. Enjoy the show. I'll turn down the lights a little bit too. Yeah, I'll look harder for spectrum analyzer, or audio spectrum analyzer. I love just a full spectrum analyzer and like a scope that isn't limited to 50 megahertz. But I just gotta be resourceful with what I have. I've already spent so much money on this stuff, so, but you know, it's my passion. So if crypto keeps going the way it does, I might just sell some of my assets just to buy the last few things I need. The ultrasonic. I keep saying it because I really want to do it, even though it's supposed to be for my future. But this too is for the future, right? And it's something that I love. So yeah, I will be, Josh. Thank you. I'll keep an eye on it. All right. Talk to you guys later. The people on the live stream. Josh mostly. A guy named Josh.
are messing up a little.
Zuzu. Yeah.